So the start node is F and the goal node is M. The goal node is M. So assume loops are detected and consider the nodes in the up. So which one do you consider first? Up, and then you go right, then you go down, then you go left. Also assume that the node is F start node and the goal node is M, and that nodes are expanded in the order in which they're generated. Right? So it's a FIFO queue. FIFO queue. So what does it mean? They're being generated. So we go up, then we go right, then we go down, then we go left. So if I started with I, then I'm going to expand I first. List the order in which the first 6 nodes are generated for breadth first search. Okay. What will breadth first search do in this scenario? Yeah. What do you think breadth first search is going to achieve or do in this scenario? Breadth first search, we say that it will go one level at a time. So if you are starting at F, right, what are the children nodes? The first one is going to be I, which is up. Right, there's nothing. Right, down there's B, and then left there is E. So this will be the first 3 nodes generated. Right? And they need to expand I. I will be expanded to say, right, we'll now have up is K, and then the right is nothing, and then F, like that. Right. So this is a loop. It will detect this loop and it will stop there. Right? And then B will go and give up, it will give you an F. Right will give you a C. Down there's nothing, and then it will give you an A. Right? E will then come and give you up will be H. Then we have got right will be F, and then down will be A, and then left is nothing. Right. So nodes, so these are the nodes that are being generated, but we only need to give the first 6. Only need to give the first 6. So how do we write it in an exam situation? Right, you simply have to list the order in which, right? So you're going to generate, it's going to be F, right? And then you're going to have I, then you're going to have B, then you're going to have E, assuming that if you do I, you're going to get K, right? And then if loops are detected, then F is not going to be considered, and then we get H, right? So you have 1, 2, 3, 4, 5. If you're not considering F as the first one, then you're going to consider after I, we do B. B is going to give us F and to give us C. So this will be the order in which the nodes are expanded. The nodes are generated in breadth first search. So you start by generating IBE, then you generate K, H, and then C.
Yes, it does from my side.
If we were to use depth first search, how different would it be? If we were to use depth first, right? Depth first, we're going to have F, right? Will be the start. And then it would give us I, right? And then I would give us, so let me teach you a trick of using the tables here. So this is number, right? So this is expanded node, and this is frontier, right? So 2, 3, 4, 5, 6, 7, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you start off with, in the front here, you have F. That's the starting point. You have F. And then you expand it. Once you expand F, you get I. You also get B. And you also get E. Right. So you expand I. Right. Once you expand I, you're now going to have K. Right. In the front here, you now have K. You're gonna have K. You're gonna have
H.
On the right. There's nothing.
Oh, on the right. Yes,
On
nothing.
down, there's a loop, and then so you're going to have H, and then still you're going to have B, and you're going to have E in the front. They're not yet expanded. Right? Then, because of the Q depth first stage, we are going to expand K. So we do K. Once you expand K, you're going to have L, and you're going to have J added, and then you're going to have H, B, and then E.
Okay.
Then next we expand L, which is going to give us M, and then we're going to have J, then we're going to have H, B, E. Then you expand M, and then you check for goal, then it's fine. Right. So if you are going to look at the node generation for this, you're going to see that when you expand F, you're still going to have I, B, and E. And then you expand I, right? You're going to have K and H. So 1, 2, 3, 4, 5. And then what's the next one that you expand, right? You don't go and you expand B, right? Instead, you expand depth first to continue going with this branch. You now expand K and you get L and lastly J. So this will be the difference between the expansion of these two. Right. I hope you get to see the difference. In tree format, I'm saying you have F, then you're going to have I, you're going to have B, you're going to have E. You forget everything else, you take here, you're going to have K, and you're going to have H, right? And then you go to K, and then you're going to have L, and then you're going to have J. So before you expand everything else, you do that. In contradiction to breadth first, which is going to say F, I, B, E, and then I, it will give you K, H. It will go on the breadth. It will now move to B. B will give you C and A, C and A, and then E would give you H and A, H and A. So this is breadth first stage, and this is depth first stage. All right. I hope this brings some clarity in the differences between the two stage strategies. Any questions? Hey.
Not from our side.
Now, the rest of the guys, are you following? Okay. You can unmute your microphone if you have the question, and then we can carry through the discussion. Right. Explain how uniform cost search differs from breadth first search. Pay attention to the data structure used. So uniform cost search, it uses a predetermined priority queue. Priority queue. Right? Whereas the breadth-first search uses the first in, first out, right? Sort of a FIFO queue. Right? To pass the tree breadthwise. To pass tree breadthwise. Yeah. So they say pay attention to the data structure. So for this, you can get your math. Additionally, if you want to discuss them, you can talk about how a priority queue allows you to is optimal. A priority queue will be optimal, right? You can talk about the space complex, you can talk about the time complex, and so forth. But those are the differences. But they said make sure in your description or stating the difference, you outline the usage or the differences in the data structure used. Like that. Right. So the simple one there. Then let's look at another question here. Assume that breadth-first search is employed and the start node is A and the goal node is J. Write down the order in which the nodes are generated. Expansion proceeds in a left-right fashion. Continue until goal test is successful. Right, what do you think is going to happen if you're talking of breadth-first search? How do you think it's going to happen? So they say write down the order in which the nodes are generated. So A is going to generate B, is going to generate C, is going to, let me draw it in a tree fashion. It's in a tree fashion, but I just need to make sure that it's. So A is generating B, C, and D, right? And then B is generating E, C is generating G and H, D is generating L, right? Then we have E is generating L, G is generating K, and then H is generating J, and then that's it. And then K is generating L, J is generating L, like this. This is in fact how the tree would look. Yeah. So if we are looking to get to when goal test is successful, remember with breadth-first search, we test for goal when node is generated. When node is generated. Right. So what does it mean? It means when it is produced, that's when you goal test. Right. Other ones see depth first. It tests when node is being expanded, just before expansion. That's when it is tested. So in light of that, so we're saying we have A, we've got B, we've got C, and we've got D. Right. And then we're going to have B will give us E, C will give us G, H, right? And then we're going to have D will give us L, and then we stop. When L is generated, we stop. Right. So write down the order in which the nodes are generated. Expansion starts from left to right. So that will be your solution. So simply writing down this is your solution. Is that fine?
Yeah, that's good.
right? Then, right, assume loops are detected and that nodes are added to the frontier in the following order: up, right, down, left. For example, if node J is expanded, there is no node of up from J, so nothing is added to the frontier for up. K is left, so so J is added to the is left of J, so it is added to the frontier, right? It says there's no up, right? We're talking of J. K is to the right, so it is added, right? Then what's next? H is down, it is added to the frontier, and then also nothing to the left, so only K and H are added to the frontier. Right? So that is the order which we're going to add. Assume that the start node is F and the goal node is M. Provide the entire search if depth first search is employed. So adding to the frontier, I mentioned earlier, that is pushing it to the door of expansion. It's the frontier is the gateway for expansion. If you're at the frontier, it means you are next, or you're the one who's going to be expanding next. All right. So that's that. So we sort of it started on that. So we can go, let's start again. We say we're going to generate F is my parent node. We're going to go up. We're going to go right. We're going to go down. We're going to go E. Then depth first search says you continue going with one branch up until you can go no more. So I've got I will now have K. I detect this loop. I'm now going to have H. Then I will go for K will give me L, to give me J. Then L will give me M, right? And then before I expand, I'll test and then I'll stop there. So assume provide the entire search tree if it is going to be employed. So this will be the entire search tree. Or simply put, one can come and write F I B A K H L J M. So before this will be the search tree. This will be the representation of the search tree. Right. Which ones will be expanded? So and that is a very good question. Yeah. Which one will be expanded? What is the path that will be taken? So F is going to be expanded, right? I is going to be expanded. So the shortest path to go. Then I'm going to have K, I'm going to have L, I'm going to have M. So this is a solution. But this is the generation of nodes. Right? Assume provide the entire search tree if the depth first search is employed. So this will be the search tree if the first search is employed. Any questions? Right. Take it there's no questions. That is how you go around, these are the most common asked questions in terms of in uninformed search strategies. We venture or we speak more on the breadth-first and depth-first search. They're examinable. Bidirectional search is not examinable. Iterative depending is a little bit involving, so it's not fond of for a 5 to 10 mark question, right? Then I think if I were to go back, let me see, there would be another question. Is the search, excuse me, up or down, assume that, so we've done that. Right, so this is an example of uniform cost search, which is the only one that we're doing then. Right. Now, uniform cost search is a priority queue, right, which is based on the estimates, right? So perform uniform cost search, assume that the start node is A and the goal node is K. Where's K? Yeah. Right. And the estimated distance to go is given in parentheses after each node name. After each node name, the actual distance between each pair of nodes is indicated on the respective edges. Break ties by using alphabetical ordering of names. At each step, specify the frontier, right, including the path cost of each node in the frontier. Use the following format to answer. So the first step has already been done for you. Right. Right. Number or step, node expanded. Frontier. Right. So number one. Right. We don't generally start with the expanded node. So in the uniform cost search, we are saying we are counting the actual steps taken to achieve a particular goal. How many steps did you take to get to the particular goal that you're at? So let's say we're starting at A, we haven't moved anything towards the goal, so we leave it like that. Then we expand A. We expand A. Right? If you expand A, you're going to have, so let's call them, from A you have B, right, which you have a cost of 7. You've traveled 7. So we're using the actual cost, not the estimated cost. Right. So AB7, we are going to have AC is going to have a cost of 7, and then we're going to have AD, which is also going to have a cost of 7. AD, which is also going to have a cost of 7. What did they say? If so, now what we see is in the frontier we've got AB, AC, AD. They both have the same or the equal or the same cost function. What do? They say in that particular case, you break the tie using alphabetical order. So we expand B, right? Number 3, we expand B. If you expand B, what are you going to have now? We're going to have, so B is now done. We're going to have A, B, E, which is going to be 7 plus 6, 13. Then we're going to have A, B, F. So A, B, F is going 7 plus 8 is going to give you 15. Right, so these are the only additional ones, right? So the frontier still contains AC, AD, ABE, and ABF. So we go to AC. Right, number 4, we're going to do AC. So if you expand C, we're going to have A, C, G, which we have 7 plus 5, which is 12. We're also going to have ACI, which is going to have 7 plus 6, which is 13. And then we're also going to have ACH, which is going to give you 7 plus 2, which is 9. Right. So these are done. So AC is done. Right. We go to AD, which is 27. Number 5, we expand AD. Right. After we expand AD, we're going to have ADH, which is going to be 10. And that's all. Right. So which one is going to be expanded next? I've got 9 and I've got 10. So this one is done as well. So I've got 9, 10, 12, 13, 15. So definitely we're going to expand ACH, which has got the least, the cheapest cost, which of 9. So if you expand ACH, so there's ACH done. If you expand ACH, you're now going to have ACHJ, right, which you have a cost of 7, 9 to 11. Right? Or you have ACHI, which is going to have AC 9 plus 3, 12. So we're going to have a cost function of 12. So now I've got 10, I've got 11, I've got 12. So I'm going to do 10. Right, I'm going to do 10. Then I'll have ADH. If I expand ADH, right, I can then get ADH I, which is going to give me 10 plus 3, 13. Alternatively, I can have HDAJ, which can give me ADHJ, which can give me 10 plus 2, 12. Then the J story is 11. So definitely we try 11. We try 11. Right. So this can be a long process. Right. When we try 11, that's number 8. A, C, H, J with 11. If I try this, I'm going to have plus 4. Right. So I'm going to have A, C, H, J, K. But it will give me a cost function of, it was 11 plus 4, a cost function of 15 now. Now, if we were doing breadth-first search, and I hope this will explain the concept of expanding upon generation in the expanding when you're expanding. With, go testing upon generation or go testing when you're expanding. Right. So you see that we have arrived at K. K has been produced now, but it is not going to be taken as the solution because we're first going to check whether or not there's no path with K that is going to be expanded first that may be shorter than the path we currently are. Right. So it's still going to remain in the front here. It's 15. We've done 11. Right. 12. I've got ACG. I've got ACHI. So ACG takes priority. Right. ACG takes priority. Oopsie. Let's see. Let me bring this down a bit. Right. If we go down a bit, we're going now to have, we're going to expand 12. So 12 is A, C, G, 12. So ACG, if G is expanded, it is going to give us ACGF with 12, that will give us 14. And then it will give us ACGI to give us 14 is 15, right? And then we have that's all. So this 12 is done. ACG, right? I've got ACHI, which is 12 as well, right? ACHI, so AC will take priority. So I'm going to have ACHI, which is 12. Right, if you expand this, you're going to have ACHI, which is going to be 13. Okay. It's going to be 13. So ACHI K, which is going to give me 13. So I've got production of K with 13 and production of K with 15. So you see that we're going to continue going. This one is going to be done first before we do this one because it is a higher cost function. Right. So we're done with the 12. Right. We have got another 12, ADHJ. Right. We have another 12, ADHJ. ADHJ, which when you expand, right, you get 16. So ADHJ. So ADHJK, right? So if this was 12, it's going to give you plus 4, which is going to give you 16. So this one is out. So we now start with the 13s, right? We have a 13 here. ACI, remember this guy? I've got ACI, I've got ABE. So ABE is going to produce F, which is going to give you 7, 6, which is 13, 16, right? I'm just going to round off here so that you can see. So you're going to have another line for this one, which is going to give us 16. And then ACI, which is 13, ACI, which is 13, right? Plus 1 is going to give you 14, right? It's going to give you 14, right? So you're going to have another line, but and then after you do that, you do all the 13s, you now come to this 13, right? When you expand it, when you expand K, then you, before you expand the test, you find that it's a goal, and then you stop. So that will be the shortest path. So it will stop when, I think, let's say, 12, 13, number 14, when you have got A, C, H, J, where is it? ACHI, HIK, 13. So this will be the solution. So this is a pretty long one, exam line. All right. Any questions?
By the way, what was the question?
So I wanted to find the shortest path from A to K.
Okay. And how many marks for this?
It was 12 marks or something. Let me see. 11 marks.
11 marks, okay.
Yeah.
No problem, thanks.
All right. So these are uninformed search strategies. Next, we need to look at informed search strategies, which will be the focus for next week. If you have no other questions,
okay. Yeah. So are we expected to write to draw this table, or
Yes.
do we need to write only the solution?
You have to draw this table because they say at each step specify the frontier, including the path cost of each node in the frontier. Use the format given. So you have to do this table. Normally, in the other one, they were just saying list, right? You would have listed this.
Yeah.
But here they're saying follow this format.
Okay. So another thing regarding the recordings, I know I'm so sure if you are willing to upload these recordings on the portal. So yeah.